Find the Laplace transform of t minus 1 quantity to the power of 4. So basically you want to expand this exponential quadratic term into its individual components. And sure, you can just multiply t minus 1 times itself 4 times, but that gets a little cumbersome. A faster way to do it, in my opinion, is by making Pascal's triangle, where you can add 1 to each edge for as many rows as there are powers. So starting with row n equals 0, row n equals 1, n equals 2, all the way up to n equals 4. So just keep adding 1s on the edge. And now in between each row, if you see 2 1s here, you can add them up to become 2, and you can add up the individual components here. 1 plus 2 is 3, 2 plus 1 is 3, and 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, so we get this final row here for n equals 4. These terms represent the coefficients. So let's say we have a coefficient a plus b, quantity to the 4th. Applying this rule here, we will get 1, a to the power of 4. We'll start off as the highest power for a and lowest power for b. And as we progress through this row, we'll decrease the power of a and increase the power of b. So we have to add the next term, plus 4, decrease a by a power of 1, a cubed, increase b by 1, so it'll become b to the 1, and so on. Plus 4, a to the power of 1, b to the power of 3, and lastly 1, a to the 0, so now this is just 1, times b to the power of 4. Simplifying, this term will become simply a to the 4th, since b to the 0 is any constant to the power of 0 is still 1, plus 4 a cubed b, plus 6 a squared b squared, plus 4 a b cubed, plus b to the 4th. Now applying that, we'll let t equal a and b equal -1 for our Laplace term. That means we'll get t to the power of 4 plus 4t cubed, b is -1, plus 6 t squared, -1 squared, plus 4 t -1 cubed, and lastly plus -1 to the 4th. Simplifying, that will become t to the 4th minus 4t cubed plus 6t squared, since -1 squared is +1. We have -1 cubed is -1, so minus 4t plus 1, since -1 to the power of an even number is +1. And this is what we're taking the Laplace transform of. So let's put that inside the Laplace. And through linearity, we can separate every term being added with each other. So we'll have 1, 2, 3, 4, 5 individual Laplace transforms. So Laplace of t to the 4th minus 4 we can leave as a coefficient, t cubed, plus 6 Laplace of t squared, minus 4 Laplace of t, plus Laplace of 1. Now we need to look at the property for Laplace transform of t to the n power. It will become n factorial over s to the n plus 1, where n can be 1, 2, 3, and so on. Furthermore, for our Laplace of 1 term, we know from our table that it's 1 over s. So let's look at Laplace of t to the 4th power. That means we need to let n equal 4. So 4 factorial for n factorial over s to the power of n, 4, plus 1 is 5. So 4 factorial is 4 times 3 times 2 times 1 over s to the 5th. 4 times 3 is 12, times 2 is 24 over s to the fifth. Likewise for t to the third, same thing, let n equal 3. Speeding it up, it's 3 factorial, which is 3 times 2 times 1, over s to the 3 plus 1, which is 4. So 6 over s to the fourth. For the Laplace of t squared, let n equal 2. So 2 times 1 over s to the power of 2 plus 1 is s cubed. So 2 over s cubed. And lastly, Laplace of t simply means make n equal to 1, since it's t equals t to the power of 1. So 1 factorial is simply 1 over s to the power of 1 plus 1 is s squared. Now we have everything we need to plug into these individual terms. And make sure not to forget any of these coefficients. They will be multiplied by what we found over here. So Laplace of t to the fourth, we said is 24 over s to the fifth minus 4 for our coefficient. Laplace of t cubed was 6 over s to the power 4 plus 6. Laplace of t squared is 2 over s cubed minus 4 times Laplace of t, which we said was 1 over s squared. And for our last term, Laplace of 1, which had no coefficient, was just 1 over s. Now for our final answer, multiplying all the coefficients inside the terms, we have our 24 over s to the fifth minus 4 times 6 is also 24 over s to the fourth plus 6 times 2, 12 over s cubed minus 4 over s squared plus 1 over s. And that's our answer. If you'd like to support the channel for more free solutions, please like and subscribe, and I'll see you in the next one.